So in the previous video, we were discussing about positive work done, and the definition of positive work done was when the component of the applied force and displacement are in the same direction. When the component of the applied force and the displacement are in the same direction, then work done is said to be positive. And in positive work done, theta is always acute. In positive work done, the value of theta is acute. And we are discussing about the examples. The first example was when a body falls freely under the action of gravity. When a body falls freely under the action of gravity, then the value of acceleration due to gravity, the direction is downward. So weight means force acting in the downward direction and displacement also in downward direction. So the angle between force and displacement is 0 degree. That's why work done W equals to Fs cos 0, which is equals to Fs and which is positive. The next example was when a horse pulls a cart, then the applied force and displacement are in the same direction. That is theta is acute. So work done by the horse is positive. So these two examples we have discussed. Now we see another examples of positive work done. Another example of positive work done. When a gas filled in a cylinder. Third example, when a gas filled in a cylinder when a gas filled in a cylinder fitted with a movable piston when a gas filled in a cylinder fitted with a movable piston is allowed to expand fitted with a movable piston is allowed to expand. Then the work done by the gas, is positive. Then the work done by the gas is positive. Then the work done by the gas is positive because the direction of gas pressure and displacement, because force due to gas pressure, and displacement are in the same direction, This is the third example of positive work done. When a gas filled in a cylinder, suppose there is a cylinder in which gas is filled and there is a movable piston fitted. These are the gas particles. So when a gas filled in a cylinder fitted with a movable piston is allowed to expand. This is the position that the gas is in compressed position. And when the gas is allowed to expand, then the force due to gas pressure acts in the upward direction. And piston also moves in upward direction. So the displacement is also in the upward direction. So the angle between force and displacement must be acute. And the force and displacement are in the same direction. The component of the force and the displacement are in the same direction. When a gas expands, thus the work done by the work done due to gas pressure, then the work done by the gas is positive. The work done by the gas is positive because component of force and displacement are in the same direction. Now the fourth example, when a spring is stretched, when a spring is stretched, when a spring is stretched, then the stretching force then the stretching force and displacement are in the same direction. When a spring is stretched, then the stretching force and displacement are in the same direction. So work done is positive. So work done is positive. This is the case of a spring. Initial position. When we applied a force on the spring, then the stretching force and displacement both are in the same direction. Therefore, the work done is positive. So the positive work done means if the component of the applied force and displacement are in the same direction. 2 points we have to keep in mind. For positive work done, if the applied force or the component of the force and displacement are in the same direction, then the work done is positive. And for positive work done, theta must be acute. Theta must be acute, where theta is the angle between force and displacement. For positive work done, theta is acute. And examples of positive work done, we have seen 4 examples. The first is when a body falls freely under the action of gravity, then the direction of weight means force and displacement are in the same direction and angle between them is 0 degree. So work done is positive. Second example we have discussed, when a horse pulls a cart, then the applied force and displacement are in the same direction and hence work done by the horse is positive. Third example we have discussed, when a gas filled in a cylinder fitted with a movable piston is allowed to expand, then the force due to the work done by the gas is positive because force due to the gas pressure and displacement are in the same direction. And the fourth example of positive work done is when a spring is stretched, then the stretching force and displacement are in the same direction. That's why work done is positive. So this is about positive work done. Now we talk about the negative work done. after positive work done, we discuss about the negative work done. Negative work done. If the force acting on a body, if the force acting on a body is in a direction opposite to the direction of applied force, if the force acting on a body if the force acting on a body is in the direction if the force acting on a body is in the direction if the force acting on a body is in the direction of in a direction opposite to the displacement, if the force acting on a body is in the direction opposite to the displacement, then the work done is said to be negative. Then the work done is said to be negative. If the force acting on a body is in the direction opposite to the displacement, then the work done is said to be negative. Suppose there is a body and the force applied on the body is F. The force applied on a body is F, and the angle with the horizontal is theta. So its horizontal component of force be F cos theta, and suppose the displacement is in the opposite direction. After applying the force on a body, there is a displacement in opposite direction. There is a displacement when a force F is applied on a body. When a force F is applied on a body and there is the angle between force and displacement, F and S is theta. The angle between force and displacement is theta. So this angle will be 180 minus theta. If this angle is theta, then this angle will be 180 minus theta. And cos 180 minus theta is minus F cos theta. So in this case, the applied force, the component of the force, and the component of the force and the displacement are in opposite direction. Theta is obtuse. So in this case, in negative work done, theta is obtuse. Theta is obtuse. And work done W equals to Fs cos theta. And if theta is obtuse, if it is more than 90 degree, then it gives the negative value. For theta is greater than 90 degree, for theta is greater than 90 degree, we get work done is negative. Work done is negative for theta is greater than 90 degree. The work done is negative. Now discuss about the examples of negative work done. The examples of negative work done. The definition of negative work done is that if the force applied on a body and the displacement, if the force applied on a body and the displacement are in opposite direction, then the work done is said to be negative work done. And for negative work done, theta must be greater than 90 degree. The examples of negative work done. The first example is when a body slides against a rough horizontal surface. When a body slides against a rough horizontal surface. When a body slides against a rough horizontal surface, when a body slides against a rough horizontal surface, then the work done is then its displacement is opposite to the force of friction. Then its displacement is opposite to the force of friction. Thus the work done by the friction is negative. When a body slides over against a rough horizontal surface, when a body slides against a rough horizontal surface, body is sliding down against a rough horizontal surface, then the force of friction acting in the opposite direction and the displacement and force of friction are in opposite direction. Therefore, the work done by the friction is negative. When brakes are second example, when brakes are applied on a moving vehicle, when brakes are applied on a moving vehicle, then work done by the braking force is negative. Then the work done by the braking force is negative because the direction of applied braking force and the displacement are opposite to each other. So the first example of negative work done is that when a body slides against a rough horizontal surface, when a body slides against a rough horizontal surface, then its displacement is opposite to the force of friction, and therefore the work done by the friction is negative. Second example is when brakes are applied on a moving vehicle, then the work done by the braking force is negative. Third example is when a body is lifted, when a body is lifted, when a body is lifted, then the work done, when a body is lifted, then the work done by the gravitational force is negative. Then the work done by the gravitational force is negative. When a body is lifted, then the work done by the gravitational force is negative, because gravitational force acts in vertically downward direction. Suppose there is a body which is lifted, so the direction of gravitational force is in downward direction and the displacement is in upward direction. So when a body is lifted, then the work done by the gravitational force is negative, because the gravitational force and displacement, because the gravitational force and displacement acts in opposite directions, acts in opposite directions. So this is about the negative work done. Firstly, we have to understand the definition of negative work done. If the applied force and the displacement are in opposite directions, then the work done is called negative work done. And in negative work done, theta must be obtuse, means greater than 90 degree. And examples of negative work done. The first example is when a body slides. When a body slides against, when a body slides against a rough horizontal surface, when a body slides against a rough horizontal surface, then its displacement is opposite to the force of friction, and thus the work done by the friction is negative. Second example, when the brakes are applied on a moving vehicle, then the braking force and displacement are in the opposite direction. And the third example is when a body is lifted, then gravitational force acts in downward direction and the direction of displacement is upward. So both are in opposite direction, applied force and displacement. Therefore, it is the negative work done. Now we discuss about zero work done. The next is zero work done. First, we have seen positive work done. Second, we have seen the negative work done. Now we talk about zero work done. So if the body gets displaced if the body gets displaced in the direction if the body gets displaced in the direction perpendicular to the direction of the applied force, if the body gets displaced in the direction perpendicular to the applied force, perpendicular to the direction of applied force. If the body gets displaced in the direction perpendicular to the direction of applied force, then the work done by the force is zero. Then the work done by the force is zero. If the body gets displaced in the direction perpendicular to the direction of applied force, then the work done by the force is zero. Work done by the force is zero. Suppose there is a body and we applied a force. F is the force applied and S is the displacement. So the angle between F and S is 90 degree. And we know the formula for work done, Fs cos theta, where theta is the angle between force and displacement. And since theta is 90 degree, so work done will be Fs cos 90 degree. And the value of cos 90 is 0. So work done will be 0. So if the body is displaced in the direction perpendicular to the direction of the applied force, then work done will be 0. The work done will also be 0. The work done will also be 0 if F is 0, S is 0 or both is 0. So this is also the case of zero work done. When the applied force is 0, then the work done will be 0. When the displacement is 0, then again work done is 0. And when both are 0, the applied force and displacement both are 0, then in that case again work done will be 0. So this is the definition of zero work done, when the applied force and displacement are perpendicular to each other. And when the applied force is perpendicular to the direction of displacement, then the work done by the force is 0, because theta is the angle between force and displacement, and when the value of theta is 90 degree, means F and S are perpendicular to each other, then work done will be 0. And the another case, work done will also be 0 if either force is 0 or displacement is 0 or both force and displacement are 0. So in both the cases, the work done will be 0. We discuss the examples of zero work done in the next video.